How does async await relate to the event loop and microtasks? Async await is built on top of promises, and since promise reactions are scheduled as microtasks, async await directly depends on the microtask queue and the event loop scheduling rules. What exactly exists is an async function that returns a promise, the call stack executing synchronous code, the microtask queue where promise continuations are stored, the macrotask queue for timers and I/O, and the event loop coordinating execution. The order is strict. When an async function is called, it immediately returns a promise and begins executing synchronously on the call stack until it reaches an await expression. When await is encountered, the expression is evaluated and converted to a promise if necessary. The async function execution is paused, and the rest of the function body is registered as a continuation attached to that promise. When the awaited promise settles, its continuation is enqueued into the microtask queue as a promise reaction job. When the current synchronous execution completes and the call stack becomes empty, the event loop drains the microtask queue, pushing the async function continuation back onto the call stack, and execution resumes after the await point. Because microtasks are processed before any macrotask, the resumed async function runs before timer callbacks, such as set timeout, which affects ordering guarantees. The causal chain is a sync function called promise created, await pauses execution, awaited promise settles, continuation scheduled as microtask, event loop drains microtasks, function resumes, final resolution propagates. If multiple awaits are used, each pause and resume cycle follows the same microtask scheduling pattern, ensuring sequential style code while still being non-blocking. Async await relates to the event loop by pausing execution at await and scheduling the continuation as a microtask, which the event loop executes after the call stack clears and before any macrotask.